Okay, here we go. 4.4. Let's do this.
44.
44 or 4.4. Okay. Parallel lines, perpendicular lines, and slopes because they all go together. Yes.
Yeah.
They do. Why? Or why do I know they all go together? How do you know if lines are parallel? That's our first question.
Not intersected.
Are they what?
They have a little triangle.
Okay, when they have little triangles on them. Let's say algebraically, how do you know lines are parallel? What? No,
They're not intersecting.
they're not. They don't intersect, correct? But think about algebra. Think about when you have something in y equals mx plus b form. How do you know if those lines are parallel? They what? What do you mean they equal the same thing? You're kind of right, but what do you mean? Great, I'm not talking about when you have a picture. Let's say you have an equation that says,
Oh, if they're equal.
if what are equal?
Correct. They both,
What's that word?
They're on the same.
They're the same. So if I have a line, right, it's in y equals mx plus b form.
yeah.
What is this in considered?
Slope.
Well, so what has to be this? What has to happen for lines to be parallel with that
The
slope?
slope has to be the same.
Oh, miracle on miracles, you know.
It was easier actually to write out the
Yes.
slope.
So if they are parallel, the slopes are equal, right? Okay, are equal. If they are perpendicular, what do we know about their slopes?
They're the opposite.
They're opposite what? It's more, be more specific. It starts with an R.
Reciprocal.
Yes. Opposite reciprocals, right? So, what you're going to do today is a lot of this type of stuff. You're going to start looking into perpendicular lines, parallel lines, and comparing with slopes. Okay? So, you need to know that if lines are parallel, their slopes are equal. If lines are perpendicular, they have opposite reciprocals. How do you find a slope? What is the equation for finding a slope?
M equals. Oh shit. 2.
What? How do you find a slope?
2.
The what? Change in y over change in x. So y2 minus y1 over x2 minus x1. You guys cannot just forget algebra because we are in geometry. You are using algebra in geometry. You will use algebra in every math from here on out. Slope is change in y over change in x. Rise over run. Okay?
Yep, that's right.
Okay, yeah. We sparking some memories here now. Okay. Okay, so with that, it says this, using line relationships to state equations. Write equations for lines B and C. Okay, so line B is this one right here. And line C is right here. We want equations for both of those lines. You know that the equation for A is y equals 1/2 x plus 2. Okay, so this equation is y equals 1/2 x plus 2. Let's start with finding an equation for B. What do I know about B compared to A?
Parallel.
They're parallel. So what does my equation have to include in there?
Slope.
What type of slope? It would be the
Same.
same. So it's going to be
Y.
1/2. Okay? The other way that I can then create this equation for B, okay, do you remember the point slope form? The equation that is, point slope says, if you have a point and a slope, it's y minus y1 equals m times x minus x1, point slope form. Okay, so I'm going to use the equation of point slope form to figure out what my equation for line B is. Do I have a slope? It is what? 1/2. Okay, can I find a point if this is on a grid? Yes, I can use what? What does it cross straight through right there?
2.
0, 0, makes my life easy, I love it, okay? So I can use, my point can be 0, 0. So if my point is 0, 0, my slope is 1/2, that means my equation is y minus 0 equals 1/2 of x minus 0. So my equation comes out to be y equals 1/2 x. There's the equation for line B. Okay, there's my equation for line B. Now, if I want to find an equation for line C, what do you notice about line C compared to line A? It's perpendicular, so what does that mean its slope is? What is the opposite reciprocal?
2.
Not just 2, it's the opposite reciprocal, -2. So my slope for my green one is -2. Now, there's a point right here that's obvious that we can choose, which is simply, I think it is actually, are they counting by halves? They're counting by, this is 10, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, so it's 0, 2, right, my point? So I can put that in point slope form as well. So I have y minus 2 equals -2 times x minus 0. So I get y minus 2 equals -2x, right? And so then I get y equals 2 my, oh, no. I want to write it in y equals mx plus 1. So I get y equals -2x plus 2. There's the equation of that line.
So you just plug in the reciprocal?
Yep.
For the,
Yep, for your
Okay.
slope. What? What? Okay. So you use point slope form. So you need a point, you need a slope. So if they give you a line, you have to first decide, is it parallel or is it perpendicular, so that you know what the slope is going to be. If it is parallel, the slopes are what? If it's parallel, the slopes are what? The same. If it's perpendicular, the slopes are opposite reciprocals, okay? Then you pick a point that's on the graph, make it an easy point for you, make it something simple, and you plug it into point slope form. You can use 0, 0, 0 if it crosses through 0, 0. Yes, like this one for green did not cross through 0, 0, that's why I did not choose it. Okay, I chose this one because it crossed through 0, 2, so that's pretty simple. Okay, so you have to choose a point that is on that line for a point slope. And then you say y minus y1 equals m times x minus x1. On these, it so happened to be that x1 was 0, so I literally did nothing because when I multiply my slope by 0, I get 0, okay? That's finding equations for lines that are parallel to or lines that are perpendicular to a different line. Okay, slope and right triangles, okay? Triangle ABC has a vertex A at 2, 3, a vertex B at 1, 10, and a vertex C at 5, 7. ABC is a right triangle with C, its right angle. Is this teacher correct when they say that? So what they're saying is this. You have A at 2, 3, right? I'm going to pretend that's like, let's just make a rough sketch of it. Let's say that's here, okay? And then let's say C is 5, 7, so 5, 7, right? Something like that. And then B is 1, 10, so it's like up here, right? Okay? They want to know if this right here, this C part, is its right angle. That's what they're trying to figure out. Is the C the right angle? Okay? We're not really sure. How could we figure out if that C is the right angle? What do you think we could do? There's a couple ways we could do this. What do you think we could do? Ideas, just spit them out. Can you use the Pythagorean theorem? That's a good idea. Maybe we can use the Pythagorean theorem. Okay. So this is A, this is C, and B was 110, right? Can we use the Pythagorean theorem? If we use the Pythagorean theorem, what would that mean?
You find the hypotenuse.
You would be able to figure out which side was the hypotenuse? Okay. How do you use the Pythagorean theorem when you don't know what the side lengths are? Can I figure out what the side lengths are? How?
By using the distance formula.
By using the distance formula. By using the distance formula. So how many sets of distance formula do I have to do?
3.
3. Okay, so if I'm gonna find the distance between, let's start with A and B, okay? A and B. If I'm finding the distance between A and B, how do I set that up? Square root of what?
X2 minus X1
Okay, 2 minus 1,
squared plus Y.
3 minus 10 squared, right?
Mm-hmm.
What's 2 minus 1? 1. What's 1 squared?
1.
Okay, and what is 3 minus 10?
7.
And what's 7 squared? Negative 7 squared? 49. So I get radical 50, okay? I can leave it like that for right now. There's a reason why we can leave it like that, because we're just comparing the side lengths, right? So I know if radical 50 is larger than radical 60 and vice versa, yes? Can you, common sense tell you that? Okay, so let's do BC. How do I set up BC? 5 minus 1 squared
7 minus 10 squared.
plus 7 minus 10 squared, yes?
Mm-hmm.
I can't get this to be in sync. 5 minus 1 is 4, 4 squared is? Awesome. And then 7 minus 10 is negative 3 squared is? 9. What is 16 plus 9? So, and we know the square root of 25 is? Okay. Now we have to do AC, right? AC equals the square root of what?
Could it be 5 minus 2?
Sure, we can do it that way. 5 minus 2 squared plus what?
7 minus 3 squared.
Yep, 7 minus 3 squared is fine. Okay, what's 5 minus 2? 3 squared is 9. And then I have 7 minus 3, which is 4, which is 16. So once again, I get 25, which gives me 5. Okay, so right now I have this. I have that AC is 5 units, right?
Mm-hmm.
Okay. I have that BC is, and I have that AB is radical 50. What does radical 50 come out to roughly?
$7.07.
7.07. Now, on a right triangle, what do you know about a right triangle? The hypotenuse is always opposite the right angle, correct?
Mm-hmm.
And the hypotenuse is always the largest side. So is that correct? Would angle C be the right angle? So you just proved that that's right. Okay? Okay? The other way we can figure it out is you can find the slope of every line, which might be a quicker solution than doing the distance formula 3 times. What is the slope of AB? How do I find the slope? Change in y over x, right? So the AB, my slope, would be 3 minus 10, right?
Mm-hmm.
Over 2 minus 1, correct? So you would get negative 7 as your slope, yes? Yes. And then if I did AC, okay, A is changing y. So, oh wait, 3 minus 7 over 2 minus 5, right?
Mhm.
And you get negative 4 up top, and on bottom you get negative 3, so you get 4/3, correct?
Yes.
Okay? And if I did AB,
And then BC.
I mean B, yes, yes. I mean BC. If I do BC,
10
I
minus
have
7.
7 minus 10 over 5 minus 1, yeah? Which gives me negative 3 over 4. Okay, so you have negative 7, you have 4/3, you have negative 3/4. What do you notice about AC and BC? They are what? Reciprocal, so they are what type of lines? And do perpendicular lines make a right angle? Yes. This might be quicker for you. That's the whole point, because we're talking about slopes and perpendicular lines and parallel lines. So if I find the slopes and I say, oh look, AC and BC connect, they're opposite reciprocals, that means they are perpendicular to each other. So yes, that's a right angle. Is this quicker than doing this? Yes. Either way works. I'm just telling you that might be a quicker option for you. Finding slopes. And less room for error.
Can I just take a picture of that?
Yeah. Okay? So when you're finding right triangles and you're trying to prove a certain angle is the right angle, find the slopes of those two lines, and if they're opposite reciprocals of each other, then yes, they are perpendicular because they made a right angle. Does that make sense?
Yeah, those are what you need.
Okay.
Awesome.
Last part. Okay, last part. Distance between a point and a line. Find the distance between a point and a line. How do you find the distance between a point and a line?
Good question.
Good question. Look at this.
So,
What could I create through this point and this line?
Another line.
a right angle.
I could create a perpendicular bisector. Perpendicular bisector. How do you create a perpendicular bisector? If something bisects a line, what does that mean it does to it?
It crosses it in 2 places.
It crosses it in 2 places. If it bisects, be more specific. It doesn't just cross it and create 2 lines. It creates 2 what type of lines? If something bisects something, okay, not a transversal. Transversal cuts through a line anywhere. If something specifically bisects something, what's it doing to that line? It's cutting it into how many parts?
2.
2, and what are they compared to each other?
The same.
The same, they're equal. So if I can find the midpoint of this line, I know where the center of that line is, yes? Or the center between this. If I can find the center, then I know how far it is from this center point to that point over there, yes? Okay. So, what is this point here? 1, 2, 3, right? 0, 3. What is this point here? They will always give you 2 points if they want you to do this. 1, 2, 2, negative 1. How do you find the midpoint of something?
Midpoint from there.
I know. How do you find the midpoint of something? Korea has it right.
I know it's the big parentheses with the
No,
finger
that's
over
the slope. Isn't it?
Wouldn't it be 0
X1.
over 2?
It is the big parentheses.
So that's why I remember it. The big
Okay.
parentheses.
So yes, it's
0
x1 plus x2 over 2, y1 plus y2 over 2, because I'm literally finding halfway between both of those x points and both of those y points. So my x is 0 and 2, right? Over 2, and my y is 3 and negative 1 over 2. So what is 2 over 2? 1. And what is 2 over 2? 1. Oh good, this midpoint is right here at 1, 1. Okay, so if this is at 1, 1, and this point is at 5, 3, how can you find the distance? The distance formula. Funny how that's not ever going away. So the distance of that is, okay, and I have 5 minus 1 squared plus 3 minus 1 squared. What is 5 minus 1? 4. 4 squared is 16. And what is 3 minus 1?
2.
2 squared is? So you get the square root of, that is my
So
distance.
the midpoint helps you find where the line.
Yes. Cool. Those are the things you are working on today. This is nothing new to you. This is like a review of algebra. Yes?